So the next few videos are going to be dedicated completely to acid-base chemistry. And what I'm going to do is I'm going to guide you through the easiest stuff first, which is just the definitions. Remember that in Gen Chem there were a lot of different definitions of acids and bases, so we have to remember what those were. And then I'm going to take you through the more complex stuff like basically chemical equilibrium, pKa's, and eventually what you're going to learn to do is predict the direction of a reaction in an acid-base equilibrium. And that's kind of cool. That's also going to be kind of the ultimate goal of this section, is to teach you how to predict that equilibrium. So let's get started with the easy stuff, okay? First of all, before we get started, you need to know your strong 6. So this is something from Gen Chem that I usually tell you don't need to know everything from Gen Chem to be good at orgo, but this is one thing that you're never really allowed to forget. If I tell you that you're reacting with HCl and you don't know that that's a strong acid, like, come on, like, you're slacking real hard, all right? You should remember your strong acids, okay? Other than that, everything else I'm going to teach you here today, okay? So what I want to do is I want to start off with the most general definitions of acids and bases and then go to more specific ones, okay? And it turns out that the most general definition is going to be the Lewis definition, okay? Now I do want to make one adjustment here. Notice that in your PDF it looks fine, but in my PDF it got messed up. So I'm just going to write base, base. We're comparing acids and bases, right? Cool. So hopefully that didn't confuse you too much, all right? So the general definition, the most general definition of acids and bases is just going to be the same as what we already learned in nucleophiles and electrophiles. Okay? So basically what that means is, remember that I said nucleophiles have extra electrons, it's a negative, and then electrophiles are missing electrons. So it's the same exact thing. What we're going to say is that an acid is going to be an electron pair acceptor. Okay? So if one of these were to be an electron pair acceptor, which one would it be? Would it be the nucleophile or the electrophile? Well, think about it. The name electrophile means electron lover, so this one would be the electrophile. Does that make sense? So anytime I say electrophile, that also means that I'm talking about a Lewis acid. Okay? Same exact thing. It's just a different way to say it. Then a Lewis base is going to be an electron pair donor. Which of these is the donor of electrons? The nucleophile, because the nucleophile has extra electrons. So anytime I say nucleophile, now you know that I'm talking about a Lewis base. Okay? And now that we've linked these two things together, now you could even predict what the reaction is going to look like based on what I taught you guys about nucleophiles and electrophiles reacting together. Okay?